What if your network grinds to a halt every time someone starts a big download? The culprit? Uncontrolled traffic flooding your bandwidth. In this video, I'll reveal how QoS policing and shaping tools can save your network from congestion disasters. Stick around to see the shocking difference between policing, which drops traffic, and shaping, which saves it, and learn which one Fortune 500 companies use to keep their networks running smoothly. The tools of QoS, policing and shaping. Policing and shaping are two QoS tools that are used to limit the rate. Policing, which limits traffic by rejecting it, while shaping keeps packets in a queue, which can add delay. Policing is often used by internet service providers who have to limit the speed of their customers. For example, on the topology, we have a client on the left and an ISP router on the right, connected using Gigabit Ethernet interface. A Gigabit Ethernet interface can operate at up to 1,000 megabyte. Now let's assume that the customer pays for a maximum connection of 200 megabyte. Then the internet service provider will remove all traffic that exceeds 200 megabyte. Without control, the flow rate would look like this. The dashed red line is the limit of the rate that the customer has paid. This is usually the CIR, committed information rate. Without control, the customer will be able to get a much higher debit than what he paid. It is the internet service provider that configures this regulation. With policing enabled, here's what the flow would look like. 200 megabyte is now the limit that the customer will not be able to exceed. Except after a long period of inactivity, this limit can be exceeded. The time it takes for the policing to be put in place. As this new chart shows, after a long period of inactivity, the customer is allowed to overtake committed information rate, CIR, of 200 megabyte for a short time before the policing intervenes. We will now move on to the second tool for limiting traffic, shaping. We have seen that policing can interrupt traffic if it exceeds its CIR, committed information rate. Well, to avoid interrupting traffic abruptly, it is possible to implement client-side formatting, which is called shaping. The principle of shaping is to queue messages until the CIR, committed information rate, drops below its limit. Without shaping to activate, this is what the client's throughput would look like. Unfortunately, anything above the dashed red line will be removed by the internet service provider's policing. And as soon as the shaping is set up on the client side, here's what the flow would look like. All packets are queued so as not to exceed 200 megabyte. This prevents the traffic from being deleted by the ISP. Now, we're going to move on to the final QoS tool, which is their congestion avoidance. To understand how it works, we will first talk about TCP. The TCP protocol controls its flow using a mechanism called window size. This allows the receiver to tell the sender how many bytes to send before waiting for an acknowledgement. When there is no packet loss, the window size increases by double. For example, on this communication between two PCs, we see that PCB receives a single TCP segment and that it acknowledges this receipt by a message of the ACK for acknowledgement type. So, as it has received this segment, PCB will inform PCA that it can double the number of segments to be sent before acknowledging receipt. Now, PCA sends 2 TCP segments to PCB before receiving the acknowledgement. The size of the window doubles again, and 4 TCP segments are sent to PCB, which confirms again by an ACK return. And for each TCP segment lost, well, the size of the TCP window is reduced by half. We will now take a closer look at queuing and see what role the TCP window size window will play. Here's an example of an output queue. There are 6 packages and there is still room left. The interface being quite busy, new packages are added to the queue. We can see that now the queue is full, which means that if another package arrives, it will simply be deleted. This is called a drop or fall. This is where congestion avoidance mechanisms come in. These tools try to avoid congestion, mainly by using TCP's own windowing mechanisms, the window size. These tools eliminate some TCP segments before the queues fill up, reducing congestion and preventing more packets from being dropped. The main strategy of these tools is to delete the packets themselves so that the device throws away much less of them than it should have in the long run. On the last diagram, we can see how it works. This is what we will detail. When the queue is empty, no packets are dropped. Once it fills up and it falls between the minimum and maximum threshold, then a small percentage of packets are dropped. And once the maximum threshold is exceeded, well, all packages will be removed. And that's it for the QoS tools.